Hello, this is Mr. Stansbury. I'm going to take you through the 15F assignment. All right, so we'll start with number 1 here. Write the converse and the inverse for these here. So if you will remember, converse, the second letter in is O, that stands for opposite, and inverse, the second letter in is N, that's the negation of. Okay, so for A, the converse will be, since we have if 5x minus 2 equals 13, then x equals 3. Converse is going to be the opposite, so we're going to put if x equals 3, then 5x minus 2 equals 13. Okay, and then the inverse is going to be the negation of that. So that's going to be if 5x minus 2 does not equal 13, then x does not equal 3. Okay, B, converse, the opposite. So if two triangles are similar, then they are equal angular. So then we're going to switch those two ideas around. So if two triangles are equal angular, then they are similar. Okay, and then the inverse is going to be if two triangles are not similar, then they are not equal angular. Okay, part C here, number C, if 2x squared equals 12, then x equals plus or minus root 6. So the converse, the opposite of that, is if x equals plus or minus 6, square root of 6, then 2x squared equals 12. Okay, and then the inverse is going to be if 2x squared does not equal 12, then x does not equal plus or minus the square root of 6. All right, which of these implications are true? Okay, so if A is an element of set A, that implies that A is also an element of set B. So basically, here's what we want to do. Let's put A inside of set A. Does that imply that A has to be an element of set B? Yes, that's true. Okay, so for A, we've got part 1 is true. Okay, for part 2, we've got, here, let's take this out now and do the second one. So if B is an element of B, so it's somewhere inside of B, so I'm gonna put it right here. So if B is an element of B, does that imply that B also has to be an element of A? No, not necessarily. It could be, but in this case right here, it is not necessarily an element of A. So the second one would be false, because all we have to do is prove one time where it doesn't work. Okay. Third one here, we've got, says if C is an element of B, so let's put C out here, again, element of B, then does that imply that C is not an element of A? Now in here, this shows that C is not an element of A, so if we instead were to take C and put it in here, because here's where C is indeed inside of B, but it also is inside of A. So then part 3, we've shown a case where that does not hold true, so that would be false. And then for the fourth part, we've got if C is not in B, so if C is not in B, it has to be out here somewhere, because that's all of B. Does that imply that C cannot be in A as well? And that is true, because if it was in here, then it would also be in part in B. Okay, so then that last one would be true. All right, and then part B, it says which of 2, 3, or 4 is the contrapositive of 1? If you'll remember, the contrapositive is both the opposite and the negative of that. So that would mean, so we have A is an element of A, implies A is an element of B. So what we'd have to do is now, first we'd have to switch these two. So now A would be an element of B, and then A is now an element of set A. And then we'd also have to do the negation of both of those, so they'd have to be not equal to, or not an element of, and not an element of. So A is not an element of B, right? Or in this case, they had C. C is not an element of B, and that implies that C is not an element of A. So for part B, 4 is the contrapositive of 1. Okay? Okay, let's move on to the next one. All right, so on this one here, number 3, write down the contrapositives of these statements. So remember, that's both the opposite and the negation. So opposite and negation. All right, so for A, all rose bushes have thorns. So then we would say if it doesn't have thorns, then it's not a rose bush. Okay? For B, no umpire makes correct decisions all the time. So if someone does not make correct decisions all the time, then they are not an umpire. Okay, let me try that again. So if someone does not make correct decisions all the time, then they are an umpire. Would that make more sense? So really what this thing's trying to say is umpires do not make correct decisions all the time. So then we'd have to say if you make correct decisions all the time, then you are not an umpire. Okay, for C, no good soccer player has poor kicking skills. Yeah, so these are kind of weird. So what you'd really need to do is like say if someone has poor kicking skills, then they are not a good soccer player. Again, I know this one's kind of a weird one, kind of like B, but if they start off with no good soccer player has poor kicking skills, then what they're really trying to say is good soccer players have good kicking skills. So then we would negate that by saying if someone has poor kicking skills, then they are not a good soccer player. Okay? So yeah, some of these are a little weird, but that's all right. Number 4, state the contrapositive of all high school students study mathematics. Okay? So this would have to be all students who don't study mathematics are not high school students. So really we should say instead of if a student doesn't study math, we should say if someone does not study math, then they are not a high school student. Okay? Part B, what can be deduced, if anything, about these statements? Kyung, who is a high school student. So since he's a high school student, we have to assume that he studies math. Okay? I write down the contrapositive of each of these here. Okay, so A. So we're going to have to do the opposite of the second one. So x squared is not divisible by 9 implies that x is not divisible by 3. Okay? B, x is a number ending in 2 implies that x is even. So we'd have to go with x is not even implies that x is a number not ending in 2. Better way to say that would be x is not even, or we could say x is odd, implies that x is not a number ending in 2. So here is number 6. W represents all weak students and E represents all year 11 students. Copy and complete. Okay. So we got no weak students are, so if the students in the W category, then they are not in the E category. So let's see. A part 1 is no weak students are in year 11. Okay. And then part 2 of that, no year 11 students are weak. Okay.